Hello, Provost Arden. My name is Nathaniel Mott, and today I'd like to discuss a few ways I think we could offset NCSU's energy consumption. Let's first consider some resources that the university has at its disposal. I specifically have chosen to examine Lake Wheeler Field Laboratory for livestock waste and GW Hill Demonstration Forest as a potential site to grow biomass. Wheeler Field Laboratory holds over 6,000 heads of livestock. All this livestock produces a whole lot of waste that isn't being used for anything at the moment. I propose doing one or two things to take all that unused animal waste and turn it into energy. We could set up a gasification system to gasify the animal waste and turn it into carbon monoxide, hydrogen, and carbon dioxide. Gasification is more efficient than direct combustion, and it would also probably not smell as bad as just burning the animal waste. Later in the project, we'll discuss incineration of SRWC and switchgrass. Incineration is more efficient than gasification, but also more harmful to the environment. Incinerators use a lot of oxygen to burn the waste. This results in greenhouse gases that are released into the atmosphere, as well as toxic ash that has to be disposed of properly. Unlike incineration, gasification doesn't burn waste. It breaks the molecules apart with heat and minimal amounts of oxygen, and then recombines them to produce syngas and biochar. That being said, gasification seems like the better option. In addition to gasifying the animal waste, infrastructure could be set up by NCSU to collect and gasify all of the municipal solid waste that the university produces. There is some smell associated with gasification, so the system being set up reasonably far from the university is a necessity. The syngas that is produced can be used directly in internal combustion engines, and that can offset the fuel oil that NCSU uses. Biochar can be used as a soil amendment to improve the soil's physical qualities, especially the ability to provide nutrition to the plants. I think NCSU's agricultural school could use this, so it would alleviate our need to find a buyer. Research on the gasification of biomass is still being conducted. Dr. Hanjing Wu at the University of Nebraska stated in an article that there is still more research to be done before its large-scale application. The other option is setting up an anaerobic digester, which is more efficient than gasification regarding animal waste. Anaerobic digesters produce biogas that's 50 to 60% methane. This methane can be burned to produce heat and electricity. With either of these oxygen-deficient systems, there would have to be some kind of way to funnel all the solid waste. The animal waste from each coop or pen could be collected in a collecting pond and then funneled further into the digester. GW Hill Demonstration Forest is our largest area within a reasonable transportation distance from NCSU. Right now it's being used for summer camps. I think it'd be beneficial to put a renewable energy facility on those grounds to both educate the campers and to produce fuels. Now let's move on to incineration of switchgrass and SRWCs. Switchgrass is a warm season perennial grass that can yield over 9 dry tons of biomass per acre. It's pretty easy to grow and all you need is normal hay equipment to harvest, which NCSU I'm sure has already. SRWCs are short rotation woody crops. The goal is to grow woody biomass as quickly as possible to produce more energy. I propose we clear a couple hundred acres of the forest to start growing and gasifying or incinerating switchgrass or SRWCs. While cleaning the area, sell the good parts of the trees and save the rest of the logging residues for incineration. We'd need an incineration facility, and after doing a little bit of research, I discovered Biogen's Power Act plant. It's a plant that takes up only 4 acres compared to the 20 acres that many other mass incinerators require. The downside to clearing the area and incinerating the logging residues is that downed wood contributes to sustainability in terms of like wildlife and erosion, site productivity, and water quality. However, we don't necessarily need the logging residues on the site because we're going to clear it completely to make room for planting grasses and SRWCs. For time's sake, I won't go into all the drawbacks of grasses, but there's some storage issues, there's some sustainability issues, some storage issues like it has to be densified after harvesting. It has to be seasonally harvested and stored. That's kind of difficult, presenting problems for year-round needs. There's sustainability issues like diseases and pests might emerge after with large-scale production. It produces more ash, and they're less diverse than other covers. Um, some other things to consider. Forest land is obviously not marginal, so it's hard to justify clearing a large portion of land just to grow an invasive grass species on it. But that being said, I think it's at least more sustainable than clearing the entire forest for energy purposes. And it's also kind of research. If we were going to end up incinerating the grasses to produce energy, a lot of unwanted CO2 would be emitted, which is a greenhouse gas that's bad for the atmosphere. There are not really any good recovery practices for CO2, so all of it that we burn will be harming the atmosphere. On a semi-positive note, in the future, if more of the forest were to be cleared, it would be convenient to already have a small-scale incineration plant on site. I think the most cost-effective and friendly way to offset NCSU's energy consumption is to set up a gasification plant to gasify everything from municipal solid waste to the switchgrass to SRWCs to animal waste, and that way minimal infrastructure will need to be set up. For the purpose of this project, I'll be assessing production based on the conversion sheets from Project 3. This table does not have data relating to gasification of SRWCs and switchgrass. In lieu of those calculations, I will provide incineration calculations for those grasses and short rotation woody crops. My estimates bring us to a total of 15,000 MMBTUs per year when we gasify NCSU's municipal solid waste, about 1,000 MMBTUs per year when we gasify all the animal waste, and about 28,000 MMBTUs per year for incinerating all of the SRWCs and switchgrass, which is a total of 44,000 MMBTUs per year. We still have a long way to go to improve our energy consumption, but that's a good start. There are offsets on the conversions sheet. For time's sake, I'm not going to go into them on the video, but I recommend reading over those and comparing them. Thank you for your time.